Welcome to the Aerospace Advantage podcast, brought to you by PenFed. I'm Doug Birkey, Executive Director at the Mitchell Institute. Here on the Aerospace Advantage, we speak with leaders in the DoD, industry, and other subject matter experts to explore the intersection of strategy, operational concepts, technology, and policy when it comes to air and space power. Now this week, we're going to continue our conversation about collaborative combat aircraft, or CCA for short. And bottom line, the service's combat aircraft inventory is too small, too old, and its readiness is too low. Decades of underfunding and delayed modernization, they've exacted a toll. But here's the deal. With threats surging around the world, the Air Force has to figure out how to reset and do it fast. And we can't just buy more of what we've already fielded over the past decades. We've got to explore new operational concepts and technologies that'll give us an edge. That's what it'll take to fight and win in a pure conflict for tomorrow. And that's where CCA come into mix. They're designed to bring new capabilities, more capacity, and empower new ways of fighting. Now, to be clear, CCA are not just, air quotes, cheap fighters to replace the Air Force's F-22s, F-35s, or F-47. They're an additive ingredient that makes the total air power package better. But like the rest of our Air Force aircraft inventory, just to buy a lot of CCA won't be enough. Credible, sustainable combat air forces require logistics. Personnel, fuel, munitions, ground handling equipment, and other material to generate sorties at scale. And that's what we're going to talk about today. At Mitchell Institute, we executed a major exercise in 2024 looking at logistical requirements, or CCA, to assess the challenges and opportunities inherent in this whole equation. This involved operators, industry partners, planners, and logisticians. And we recently released the report. So today, we've got some of the key actors who are part of that effort. First and foremost, our project lead and report author, Mark Gunzinger. Next, we've got Otis Winkler of Kratos, Andrew VanTimmeren of Anduril, Scott Gilloon of General Atomics. And just to clarify, you can probably guess it by their call signs, but all of these folks are prior combat pilots, and they've got a huge bench of experience. So, gentlemen, really appreciate your time. Welcome.
Hello, everyone.
Yeah, thanks for having us.
Yeah, appreciate everybody. Thanks for the opportunity to be here.
So I want to foot stomp a key point up front here at the outset of this episode. And I think there's a common belief that we're looking to acquire CCA because they're, air quote, cheap. And I think that really misses the point. Of course, lower cost is good and everybody be a fan of that. But what we're really talking about here is harnessing a new operational concept that other aircraft simply can't match due to the kind of the virtues and capabilities and unique elements of these aircraft. And who wants to expand on that? You're all the experts.
Yeah, I'll start with that. I'll go against my 15 years of brainwashing from my tenure in the Pentagon and say it's far more important to understand that China can now project more combat mass into the Taiwan Strait region than our Air Force. China has the largest Air Force in the Indo-Pacific region, and they're outpacing our production of modern combat aircraft. So you hear a lot about the PLA Navy and China's shipbuilding capacity, but not so much about the growth of its Air Force. Here's the point. Our Air Force cannot match China fighter for fighter, just as the U.S. Navy cannot match the PLA Navy ship for ship. Instead, they must field asymmetric capabilities. They can achieve outside effects that offset China's combat mass advantages. And that's the reason for why our Air Force is buying CCA. They're going to be force multipliers that are capable of disrupting China's air defense operations and causing them to react in ways that advantage us.
Yeah, I can't agree more, Gonzo. I think that cost is important, but I think the key to this is the disaggregation that comes into it, right? We're disaggregating all our sensors and all our weapons
Bingo.
To give a much harder problem to the enemy. And at the same time, we're able to acquire more in mass, and it has to be affordable, and it has to be capable. Right? We're not looking at quadcopters that are going to take off and go do something potentially like you see in the Ukraine. Right? We are actually applying combat power with capable, survivable aircraft to be able to attack the enemy, and to be able to drive timing and tempo of our forces, keep control of that, as opposed to handing it off or ceding that space to the enemy. I do think cost is important, though, and I think that what we've discovered in doing this is that we can build an airplane. We buy airplanes by the pound, dollar per pound, and we can build airplanes now for about $800 a pound, which is different than what we've done with other aircraft, right? So we're driving down that cost. The aircraft themselves, we're driving down significantly with advanced manufacturing and the like. What we're not driving down And what we haven't spent enough time and effort on are affordable but capable mission systems and affordable weapons, right, that are built to be able to be used by CCAs.
I think the other part of this too, and to piggyback on what you guys have said so far, is the overall effectiveness of the capability. Up to this point, we've been leveraging some amazing work with these ISR-focused vehicles in a permissive environment. But when it comes to the overall effectiveness and that cost per effect, which Mitchell does a great job of advocating for, it makes a lot of sense. The roll-up of effect also includes its ability to be sustained, its ability to be delivered, its ability to be leveraged in many different locations. And that gets into that overall supportability. And so I think one of the greater things about this program as well, when it comes to CCA in a paradigm shift, is the ability to disaggregate those logistics and be able to support it in very challenging but novel locations. I think that's one of the key things that we learned out of this TTX, and we're excited to get into it today.
So I'll add a couple things here. I think about where we've come from, as Scar points out, ISR and various levels of permissive environments or in different regions around the globe. I think when you look at cost, it's certainly an aspect of it. But I think what's maybe more important, or the piece that's more exciting, is we're really kind of talking about a new way of fighting. Right? So this is the introduction of autonomous collaborative platforms. This is something that enables our new tactics, techniques, procedures, so the TTPs for the Air Force. So new ways to manage risk to personnel and the platforms, just a new way of fighting, new mechanisms to help us achieve mass and maneuver. So this is something, I think that we have to put it in terms of historical scale. I love looking back at General Mitchell and what he recognized in the interwar period of what we could do with air power. I think in a similar vein, I think we're going to witness changes on that type of scale and how we perform missions such as air dominance when we look at it, whether it's OCA or DCA. And I think those are some of the things that we've seen in the workshops, is that it just fundamentally changes how we fight. But one of the key pieces that we tend to overlook sometimes is the iterative cycle that these new ACPs or CCAs in this case, what they give us. So this is something that I think we can take a lesson from Ukraine. I'm sure everybody takes lessons from that fight. But one thing that I think we all agree upon is that the iterative cycle in that fight was unlike anything previously encountered in warfare. It's very, very rapid. So in this case, how do we apply that as sort of iterative cycle in air combat? I mean, to me, that's really exciting, but it's also challenging, I think, because there's like no, I'll call it clear or unified end state, no singular moment right now where we say, hey, that's what air dominance looks like in the future. So you can either be slightly nervous or excited. I guess maybe that depends on which side of the CCA fence you're on. But I do think it's important to say, or at least to kind of note, that maybe we take a lesson from General Mitchell and all that he realized, and the potential for aircraft to generate different effects at a pace, at a scale that previously was unknown or unrecognized, and how that contributes to that development cycle and that iterative cycle, and when we put those capabilities in the hands of the warfighter.
No, I really appreciate that from all of you guys. And Fug, you talk about the historical element, and we kind of think the development, counter-development in World War II, something like electronic warfare or other things. I think we're going to be in for a very dynamic race when we get into the future operational environment. And so having a lot of intellectual talent on here is going to be crucial to keep this advancing. So Gonzo, I want to ask you to walk us through some history specifically to this exercise. This is the third in a series of CCA workshops that Mitchell executed. Walk us through the building block approach you've taken with these. I think it's really important for the audience to understand this. Where did you start, and how did the line of inquiry progress?
Yeah, so it was a classic force development effort. Our first exercise explored the art of the possible for uncrewed systems technologies. Experts in the Air Force and industry postulated 10 notional CCA designs for different missions. But overall, they recommended designing the Air Force's initial CCA increments to perform a range of offensive and defensive counter-air missions. So our second exercise explored how CCA can be used in ways to achieve air superiority against China, and not just how we've operated in the past, but in new asymmetric ways. And one of the biggest takeaways from that game was that CCA should be more than loyal wingmen to fighters. Expendable and recoverable CCA can also be used as a primary force to complicate China's air defense operations and and create that uncertainty that causes the PLA to honor the threat and burn its sorties and use up its weapons. And that can create windows in time and space for the Air Force to launch strikes and complete other missions.
No, and I think it's really a compliment to you too. When we think about the service industry, everybody was learning a lot about this capability kind of on this curve that's it's real time, and you're anticipating what they needed to look at. And that's why we saw the reports harnessed a lot, because you're a step ahead of the game, and really hats off to you. The rest of you played in these efforts. Thoughts, Stat, on them?
Yeah, I'll add. I think Gonzo and Mitchell in general did a fantastic job at being a thought leader in this. The Air Force was trying to work their way through things, not publicly. There was a lot of people in the open press that were talking about things, but nobody had coalesced around some kind of an idea and a methodology in order to get this done. And I think Mitchell stood up with, okay, let's figure out what we need, and then let's figure out the mission, and then let's figure out how to operate it. And I think that what made it really, really compelling and something that you can take a lot of lessons learned out of it was the fact that everybody came in with their own ideas in the beginning of what they need, and we used that stable, if you will, of CCAs. And now as you figure out what missions you're going to need and are going to be game-changing in the Indo-Pacific, and then what the logistics requirements are, we can start scoping that down and really finding the right attributes. And I think that is the biggest takeaway, and we were talking about it a little bit earlier. I think it has already changed the way that all the services are looking at CCAs.
That's huge. So, Gonzo, bring us up to speed on the third iteration. Why logistics? What were you trying to better understand here?
Yeah, that's an easy question to answer. No military force can be combat effective without the weapons and other resources it needs to sustain its operations. So that's why we led a CCA logistics game, and not to quantify specific CCA logistics requirements, but to better understand how those requirements should inform CCA development, their operating concepts, even their forward postures. And that should be part of the Air Force's CCA Force design effort, not an afterthought after the Air Force in being. And it's great news that the Air Force is doing just that. It is informing its CCA development by looking into logistics right up front. And credit to everyone on this podcast who were thought leaders in our exercises. We could not have done it without you. Thanks, gents.
So you had some unique partnering with Air Mobility Command in making this happen, right? I mean, how did that help really develop the process and the execution? Because you really had the real experts in the room that own this stuff.
Yeah, we sure did. Our approach was to pull together the right operators, planners, technologists, even a scattering of strategists to participate in our workshops and our war games. Now, that includes, of course, everyone in this podcast. So our reports really represent their thoughts, their creativity, not some policy wonks idea of what a future force should look like. There are a lot of those reports running around D.C. Mention AMC, Air Mobility Command. They sent us their best to our last exercise, and we took full advantage of their expertise during gameplay. I'd like to thank General Minahan, who personally flew in from Scott Air Force Base to kick off the exercise. And another big thanks to Al Lois, AMC's chief scientist, who pulled together a lot of information in a very short period of time to make our game possible.
No, that's awesome. So Otis, Scarfug, you're all experienced fighter pilots. You've flown types like the F-16 and F-22. Talk to us about what sort of logistics demands those aircraft require. And if you could, contrast that with what you observed in the workshop. Does CCA help change the logistics burden? Scar, let's start with you, and then we'll hear from Otis and Fug.
Yeah, I appreciate the question here, Doug. And I'll start off with my perspective from the Raptor. And I'm going to leverage some publicly available information so listeners and viewers don't have to think that this is not available. You can go online and find a GAO report, Government Accountability Office report from 2022. It talks about F-22 mission capability rates amongst other aircraft in the Air Force and in the Navy. And it describes how in the Raptor from 2015 to 2022, the maintenance availability rates of these aircraft actually dropped. As we continue to operate these aircraft, they dropped to just hovering around 50% at the time of publish in 2022. You then go, why is that happening? why is this aircraft that's an amazing platform in the world's greatest air superiority fighter, why is its mission availability dropping? Well, they go into those details. And it is a great lesson for us to then take forward, and we naturally did in this TTX and the ultimate report. So what are the major culprits that they describe? Number one, there are unique parts associated with the propulsion system. The Pratt & Whitney F-119 engine in the Raptor is an amazing power plane. Gives you all sorts of thrusties, saved me millions of times because I'm terrible, but it also is a single engine for a single platform. There's nobody else that uses it. And so it has a very small sustainment pool to try and to create that demand. So that means that the overall logistics footprint in those companies and second and third tier suppliers may get out of business if there is not a larger demand by a larger pool of vehicles. Second thing would be LO maintenance. Many of the avionics are behind panels that then the LO could be damaged, and then that requires a lot of time to repair. So how do we fix that? And then there's an interesting anecdote, I thought, in the GAO report, which is really funny, that not ha-ha funny, but interesting funny, is they have a direct quote from a Raptor maintenance team saying they waited 239 days for a particular landing gear component to be manufactured and delivered. Then that means that jet is down for 239 days for landing gear. So like, those are three things that you go, well, how do we fix that? And I think bring this a step higher. Many of these wars are won at the mission planning table. I think people have heard me say that before. It's critical to understand. And as amateurs talk tactics, professionals talk logistics. If it takes us 239 days to get a part that's critical for the success of an aircraft getting off the ground, then we may as well just not fight. And so what it comes down to is these vehicles, I'll just go back down the list. Propulsion, having readily available propulsion that's commercially supported worldwide. Those avionics panels being designed from its inception to be easily accessible and not damage survivability. And then that landing gear, we talked about the design of our landing gear to be able to be manufactured out in the field by machine shops, globally. And so just increment one CCAs, as Otis has said, and I've heard Fug say this as well, I'll just continue to kick this horse, is they are designed from the very beginning to be producible.
Hear, hear.
They are designed from the very beginning to be sustainable then. And then that facilitates the change of the nature of the conflict that these things will support.
Yeah, so I wholeheartedly agree with Scar. And I think that there's some fundamental things that came out of the workshop or the TTX in the turning of sorties, right? And the ability of rather than using single point refueling, which is what every single fighter uses because you want to get a lot of gas in there fast. These CCAs really can use organic residual gas that are at the airfields or the locations that they will be based at. Right, and you can do overwing refueling, and so now you reduce the amount of specialized equipment that you're going to need, and you reduce the logistics strain of getting that fuel in. That was one of my biggest takeaways was the ability to leverage all things in the first island chain, all those residual areas that have fuel that we can use for CCAs in these very small or no runways available as we spread out throughout this first island chain, which I thought was incredibly important, as well as the loading and unloading special equipment, whether it's test equipment or whether it's the ability to turn the aircraft without using specialized equipment, just regular computers, if you will, a laptop that you get with a cable that you can click in, as opposed to using specialized equipment that has its own unique power supplies. All of that came out, a lot of which had to do with the fact that AMC was in there participating with us.
Yeah, go to your local general aviation airport and ask yourself, could you turn something in a couple of
yeah.
hours with driving a truck up and offloading some stuff if you can?
Not a bobtail, but just a regular Ford F-150 or something else along those lines. Yes.
No, totally. Fug, any thoughts?
Yeah, so I think Scar and Otis have really hit on some important parts that I'm sure, everyone would look at. Where do we turn from? What airfields are available? What's going to be available at those airfields? It's not that we can, when we look at agile combat employment, it's not like we can pre-position every piece of equipment across the entire Pacific, in such a region. So there's an airlift component there, or an airlift burden, but there's also just a simple basic equipment. How many loaders do we have for aircraft? How are you going to load the weapons? All of those pieces that are so important in matching this concept with real aircraft. But I think what we can also do is kind of, we can all understand that you don't get away from the basics. Like combat aircraft require fuel and they require weapons. And so how we move those, so the larger trends here, how we move those assets around, where we pre-position them, I think that's where we start to look at maybe extrapolating data over longer periods of time and understand how increased sortie counts we talk about. And hopefully we'll get into some of the advantages that CCA would bring to the fight and what we saw in the workshops and what we see in various war games. But as we start to do more we increase the frequency of those sorties, well, there's more fuel and there's additional weapons. And so I think you start to see various concepts, and what's really, I think, opens everybody's eyes is that now we start to talk about things like collaborative mobility aircraft, right? So how do we help use CCA concepts to alleviate airlift burdens? When we have CCA, how do we actually build an aircraft or design an aircraft where we can deploy it in larger numbers with fewer requirements, right? A smaller footprint. We're leveraging, I think, as Otis was pointing out, we're flying into a field that's a general aviation field. What can we leverage off of that field? So we have the opportunity to look at that. That's where a traditional fighter squadron or something like, when you deploy in, there are a sky full of C-17s that fly in and help set up the infrastructure. They bring all your standard equipment. So I think it's, CCA, when we talk about executing ACE and what we saw in this and other workshop, is that it's imperative that you start from the beginning when you look at how how you expect to employ the aircraft, where do you expect to fly it from. And so it's not just about the increased sortie requirements. It's that, hey, if we want to get to increased sorties, how are we ensuring that every type of fuel delivery is available to our aircraft and that we can use it? Multiple different weapons loaders that might be distributed around the Pacific, both what we have and our allies have available to us. How can those be leveraged for these aircraft? So it's really an entirely different concept in that way. It's something that was, I think, a highlight of this workshop, or a specific benefit of this workshop, where we had all of the experts in the room. So if there was some hand wave moment where we were trying to say, hey, we're just going to fly in more logistics, we're going to fly in more supplies, we're going to do this, we had the mobility side in there, the experts who would say, no, that's not possible, or that's not available, that we don't have that number of booms to support the fight, or that number of C-17s. So it really kind of set the bounds. But I think in a similar way, it validated a lot of the assumptions that I'm sure Scar and his team had taken, as we've taken at GA, and our approach to employing CCA kind of under the ACE concept.
Now, if I go and stick with you, we've spent the last 20 years operating in generally permissive operating environments. Can you explain to us the bad habits that the force may have learned when it came to logistics, and why we need to think about changing our approaches when it comes to the future fight? I mean, airfields are going to be under attack in a very different way. We're not going to have these mega bases where you can just kind of churn every day.
Yeah, so several times on the air mobility leadership, we've heard them describe what it's like to move parts around in theater, right? And so when you have the luxury of moving 200 pounds of parts or components with a C-130, and you can do so uncontested, well, that definitely creates some bad habits. I think it makes for a much different attitude towards how we sustain those aircraft. Because, in the past, we've had the luxury of sourcing, deploying, supporting expeditionary forces with logistics that are constrained principally by the airlift side, their mission capable rates. All right. So in this way, I guess, our logistics are governed by kind of that single constraint, but it's not what we would expect given our lessons. If you look and kind of take a broader view over the history of using air power, and certainly not in the types of threat environments we're talking about with the peer adversary. So in this new era, or kind of going back to the past when we fought peer adversaries, logistics for us, though, becomes part of that digital engineering. So that, as I was talking about before, it's the way that we build and we design and build an aircraft. It's taking into account the logistics tail up front so that we understand what the support requirements will be. So that's kind of the digital engineering that underpins that aircraft development process. That's how we wrap the logistics requirements back into the design. So every decision in this case, it's really a series of trades that impact supportability, maintainability, or really, and maybe put more simply, the level of effort to achieve high aircraft mission capable rates under sustained combat operations. And that's something that historically you start with a mission capable rate. And generally speaking, as you increase the intensity of combat operations, it's not like their mission capable rates traditionally increase or improve. What we've seen, at least on the General Atomics side, is we can sustain high mission capable rates when we wrap that digital engineering back into the design of the aircraft, and we continue to iterate that way. So if I can kind of distill this down to simply the number of times where I only need to supply fuel and weapons, right, and move away from the number of times I need to fly components in, I need to try and source a C-130 to fly 10 or 100 pounds of parts, then I can start to move away from potentially, at least, some invalid assumptions of unlimited resupply capacity, and maybe toward a more agile scheme that sort of continuously optimizes locations to refuel and reload, even while under that constant threat of attack.
Now, I'm really reminded of the imagery of C-130s resupplying Quezon or Vietnam, where they didn't even stop. I mean, they literally rolled stuff out the back and kept going because it was that dangerous. And that really puts a point on the fact that you got to make hard choices about what flows in and out.
Yeah, I agree. I think that in the last 20 years, we've controlled for efficiency, right, as opposed to controlling for resiliency. Yep. And I think that drives all your bad habits that Fug just got done articulating. And I think we've now, and in this TTX, we started moving towards the controlling for resiliency, allowing multiple capabilities, right, having a backup plan to the backup plan. And I really think it made a huge difference. I think one of the things that we ended up finding out was, as Fug mentioned, we could take small CCAs or small aircraft to move small amounts of things and drive your resiliency and the efficiency at the edge from a logistics point of view. And that was one of the big takeaways that the strategists at AMC came up with, which I think was a huge thought leadership exercise for us to be able to undertake.
PenFed checking and savings accounts are here for all your adventures. From
do you take this man to be your husband?
I do.
To
he has your eyes.
He's perfect.
Learn more at penfed.org. Federally insured by NCUA.
Otis, another point the workshop explored was the idea of basing locations. And we've talked about it here, mentioning GA airports and stuff like that. Folks in the exercise anticipated that CCAs would operate closer to the threat environment than normal aircraft. What drives that, and what does it mean from a logistics perspective?
Yeah, so one of the big takeaways that came out of the second TTX that we ran was the closer that you get into the first island chain to be able to survive and operate, to generate sorties, allowed you to control and drive timing and tempo for the enemy, and ceded no space to the enemy at any time. So we had at least challenged their air superiority 24 hours a day, 7 days a week, right? Which really was the biggest game changer that I had seen in a TTX in a long time, right? It was the key to success and the key to winning. Driving into that first island chain, being able to launch and recover sorties, quickly turn them, even when there were no strike packages moving in and during that pulsed operations stuff game plan that we're running. What that forced us to do, though, was in that first game, we didn't have enough time to actually drive down to the logistics. And so we had to essentially hand wave away the logistics. And I think most people that walked away in that second game was, wow, this works out great, but the logistics are going to be almost impossible to be able to do. Well, we walked into this next one, the last one that we just finished, right? Understanding that we needed runway flexibility, right? We needed to be able to get launch and recover sorties, not necessarily from a piece of concrete or from an alternative to a normal traditional runway, up to like 2,000 feet of length somewhere inside the first island chain, and to spread our forces around. And what we discovered was using the small things, small aircraft to do small amounts of equipment to these disaggregated forces, we gained efficiencies. And it was easier to actually provide the logistics. And it drove down the logistics requirements. Things like we talked about already about using organic fuel reserves. Right? The only things that we, and as Fug and Scar said, the only things that we really needed to get to the force for the first 3 weeks of the exercise was munitions. Right? And we could do that with these small collaborative mobility aircraft that we had fielded. Again, a huge takeaway, and again, a huge thought leadership exercise for everybody when we walked out of that thing saying, wow, distributed forces in the first island chain are survivable, right? They make a huge operational difference. And now it turns out that if we do this right, it is 100% supportable to the logistics, and it drives down the logistics requirements that we may see out of a main operating bases.
Yeah, the history of warfare tells us that if you afford your adversary sanctuaries in time and space, you're giving them a huge advantage to recover, to regenerate, and to go on the offensive and seize the initiative. One logistics insight that I'll riff on, something you said, Otis, basing CCA as far forward as possible could reduce or even eliminate the need to refuel them in the air. And that could help free up offload capacity for the Air Force's fighter and bombers. But there's really a balancing act here that you have to consider when you're thinking of force postures. Yeah, there are clear operational and logistics benefits from posturing CCA as close to the WES as possible. But that can also increase the risk of air missile attacks on their locations and to C-130s that are resupplying CCA. So finding the right balance between where CCA are postured in Westpac and the threat should be part of the development effort. It's not something you want to do in the middle of a fight for certain, and it shouldn't be a pickup game.
If I can add, definitely amen to what Gonzo was saying, that CCA provide combat firepower with that dramatically lower footprint, right? So what does that really mean? I think when we look at how we move around a battle space, less certainty that any set of attacks is going to significantly impact overall combat firepower, what we're bringing to the fight, right? So just by simply lowering that footprint, we've opened up a different set of operations. We've given the combat planners, the warfighters, the ability to maneuver around the battle space and the agility to really drive the fight in ways that inject uncertainty into the adversary's targeting game plan, right? So faster refueling and rearming means that I generate more sorties between the pulses, right? So I achieve more continuous, or maybe a better way to say it, it'd be less episodic air superiority or air dominance. So now I'm injecting a problem, a sustained problem for my adversary. And now good luck trying to target me because of my distributed operations, low footprint. You've got to figure out where I'm going to go next. So now I've put an element of predicting into your targeting chain. So here, I guess, at least when we look at it and when we assess kind of from a TTX, what are some of the impacts? I look at the, imparting greater difficulty resupplying forward elements. So if I'm able to sustain that air superiority long enough to cover the exposure that my resupplying network ultimately incurs driving further across the Pacific. So there's this balance, right? If I am forward, then my resupply chain has to drive further to support me. Well, if I can now distribute amongst various bases and create more flexibility in that tail because I don't have that high manpower footprint, well, to me, that's kind of bringing it back in balance, right? They may be driving further ultimately across the Pacific, but I've also given them various options as to where they can focus the forward-based logistics versus kind of that single point hub or something.
So on our report rollout, a lot of what you guys are saying about this notion of sortie density and why we need to really keep the pressure up 24/7. General Kunkel of Air Force Futures, he talked about that need to sustain that constant operational tempo to keep the adversary stressed. And it's a huge challenge given the small size of today's Air Force. And Scar, you can speak to this better than anybody. As a member of the F-22 community, it's one of the most amazing airplanes ever invented. But we just don't have enough. We never bought enough. And so how do you see something like CCA partnering with something like F-22 helping change that math? We've touched upon parts of it, but I want to hit this pretty directly here. It's so important.
Yeah, no, absolutely, Doug. I think, when it comes down to the impact these things will make when it comes to operations and then also maintenance and sustainability, I'm just going to lean heavily on, it always comes down to the man and the machine, the person and their equipment, because people require crew rest and humans do have limits, rightfully so. It's just the way that we are. And even when you take a platform like a cargo or tanker or some other platform and you have multiple crews to keep the airplane airborne longer and you force extend, you still have to allow, once they land, that entire crew base to recuperate. And I know the Air Force is the smallest, oldest, least ready, as Mitchell has said many times. that is a equipment and the hardware kind of look, but we also are short on operators. There's no secret here that we're short on the people who will operate the pilots, whether it be fighter, bomber, mobility, etc. And so we have to be able to create combat capability without putting increased demands on the A1, on maintenance, on operational personnel. And so what these things will enable us to do is have that 24/7 cap, that 24/7 ability to operate and provide deterrence, sensing, and if needed, meaningful tactical capability with successful handoff from their crewed platforms. And so instead of needing a rotation of Raptor or F-35 or in the future F-47 or Super Hornets providing defensive counter-air with the opportunity to turn it into offensive counter-air doctrinally, I think we want to leverage these capabilities to support that mission set in the absence of people. Because we should assume we will have challenges moving people around during these highly contested engagements. That is pretty logical to assume. And so how can we continue to support the CFAC, support the combatant commander in their desires for that day? And it really is going to be using these unmanned systems that have low logistics demand signal and are easily turnable by folks that are untrained. And so I think that is, as General Kunkel has said, and you allude to in the onset of this question, 24/7 operations. Let's go do it. Totally agree with you. Let's go do that. It's only going to be able to be conducted through the usage of these unmanned systems that provide combat relevant capability in that threat arena.
No, that's an awesome answer. And Gonzo, I want to turn to you and let's cut to the formal findings of the report. And we've talked about it here. We've got to minimize the footprint logistically, for the Air Force's CCA Force design. Look, I get it. It's obvious, but there are layers of depth to that. Can you walk us through some of the specifics that the participants discovered?
Sure. Let me riff on something that Fug said. It's more than reducing the strain on the Air Force Mobility Force, which is already undersized, just like the Air Force's other inventories. Smaller CCA logistics footprints on the ground will reduce the time and effort required to frequently change your locations. And that's also something that General Kunkel mentioned. So that, combined with minimizing their time on the ground between sorties, will make it more difficult for the PLA to find, fix, and target them. And getting inside the PLA's targeting cycle is a key to the Air Force's ACE concept. It's a key to a more resilient combat force. But we're not going to have that resilient force if you must support CCA with unique equipment for every variant that the Air Force fields. By bringing in all the fuel and munitions and parts and so forth that you would for a fighter squadron, you're just not going to get those reduced footprints. You're not going to get that resiliency, the ability to move frequently around the battlefield, maybe between sorties even. Take off from one location, do your mission, CCA comes back to another location, refuels, C-130 lands, refuels it, weaponizes C-130 takes off, CCA takes off, and so on. Now, those are the kinds of resilient operating concepts we need for our CCA.
So, Otis, Scarfug, how did that really approach how you designed your CCA? I mean, you've talked about digital engineering, simplifying production, stuff like that, but you had to, no kidding, sit down at a table with your engineers and figure this out, not just notionally, but with specifics. And that's got to be very, very difficult because these are very sophisticated platforms at the end of the day. And yet we're trying to simplify how we go about this. Otis, let's start with you.
Yeah, I think in order to get to the levels of the numbers that we need to make a difference out in the field, you have to start with the first principle of producibility or manufacturability. Yeah. Right? And that drives the fact that you want, and because of cost is rolled into that, you want to be able to manufacture and produce this thing at rate and at scale, but not build it like you would a normal aircraft. If you look at an unmanned aircraft, not to bash on anybody else, but if you look at an unmanned aircraft that was built before we started down this kind of a road, the MQ-25 is a great example, right? It's a great airplane, right? But it costs just slightly less than a tanker, and the mission set that it does is tanking, right? Because they built it utilizing the same tools and capabilities that you would a manned aircraft. It's very hard to scale that because of cost, and it's very hard to scale it just because of the producibility that's built into the design. So first principle wise, we make it producible and manufacture it available at cost. And then you make it a lower logistics footprint. And then you make it survivable enough to do the mission requirements, and to survive, to get the mission done, and then come back. But it allows you to modify your risk calculus as you move forward to survivability and mission completion. Things like the logistics that we already talked about, like overwing refueling, right? Being able to use the general aviation capabilities that you'll find out into the field. The aircraft you need to build in the idea, and Scar already mentioned it, all the stuff that we have exquisite manned aircraft out there that takes a little bit of time to turn the aircraft. We have to make sure that these aircraft can be refueled, right, rearmed, and get back up into the air faster, significantly faster than a manned aircraft would. Right? And then we want to be able to have the flexibility to be able to base things anywhere. So we reduce the number of manpower, we reduce the number of people that have to turn the aircraft, right? And we we increase the amount of things that can go onto the aircraft as well. That way you're not restricted for that one piece of the nut that goes on the F-22 landing gear that keeps it down for 200 and something days. You can use any traditional thing that you're going to have on the field, or you're going to allow your great maintainers to go ahead and produce it on site to keep these things airborne.
No, it makes a lot of sense. So, if you look at this new construct here and what you guys are describing, how does that really change the game on the ConOps piece? Because I'm guessing it's going to allow you to take different risks or pursue different lines of application that you normally wouldn't think about with standard aircraft, because it just wouldn't pass the common sense check. Fug, what are your thoughts on that?
Thanks, Doug. It's one of the advantages of this type of TTX is that we're able to explore kind of the bounds of CCA, right? So we're able to look at the left-right bounds, the corner cases. We're able to look at areas when we focus on runway independence and setting some definition to it. Right? We're able to look at expendability on an air vehicle. What does that mean? How do we measure a cost per effect? I think a lot of times it may seem intuitively obvious that a lower cost CCA enhances the mass side of the equation, but it's also about the desired effect, right? Are they achieving the effect that the combatant commanders of his intent of what they're trying to orchestrate in the battle space? And so it's about the balance of capabilities, the balance of effects that various CCA would bring to the fight. For example, let's say we take an air-launched expendable uncrewed system, so something like DARPA's Longshot, and we combine it with a CCA that is generated close to the fight, so something closer in, just as we were talking before. There are now new, different, novel air power concepts that apply here in this interpulse period, right? This is a collaborative now series of uncrewed systems or combat aircraft that is affecting the fight. So now, where U.S. forces will seek to maintain air superiority or otherwise deny an adversary exclusive use of the high ground, we have this capacity and this mass to surge these effects, right? It's whether it's an air launch, whether it's a ground launch, it doesn't really matter. But we have the ability to manage effects across the battle space, to inject that uncertainty in the adversary's game plan, so they never know exactly where or when we are going to strike them. So low-cost cruise missiles certainly, or other air-launched effects, they certainly play a role in the larger kind of offensive counter-air, or in this case, maybe defensive counter-air, right? And how we manage those effects or those impacts across the battle space. And we saw that in the workshop. We see it in this TTX. We see it in previous TTXs that Mitchell has organized, but it shows this particular distinct advantage, right? When lower cost platforms are combined with something like our Increment 1 CCA. So now we're posing this credible threat to the adversary. We're holding their assets at risk, but it significantly increases battle space complexity. So we're driving the fight rather than kind of sitting back and being in a reactive mode. Different CCA, the combination of those effects allow us to drive the fight in ways that we haven't been able to previously.
So Gonzo, you wrote about the need to rapidly field and develop CCA inventories at scale. I mean, we talk about all the time the Air Force is too small, so implicitly we got to grow it somehow. Why did your participants think that was so important, and what's the logistics tie into that finding?
Yeah, that's a key finding from all three of our CCA exercises. New technologies that are not on the ramp can't deter, and they can't fight. So that's why the experts that played in exercises agreed it's time to get CCA into the hands of the warfighters so they can experiment with them and find new, innovative ways to operate them that we have yet to imagine. And that includes new ways of discovering how to sustain CCA operations to reduce logistics tails. So I think everyone here would agree that the number of CCA sorties available to warfighters will be incredibly important. To be frank, I was surprised by how many CCA the experts wanted to push into the fight during our exercises. High hundreds, and in the case of lower cost expendable CCA like the long shot, more than 1,000. You simply cannot project that kind of affordable mass with an undersized force.
No, absolutely. So, Scar, we're all jealous of you. You're the former Raptor pilot. So, exercise participants didn't push the idea of trading 5th gen capacity for CCA. They wanted both. Walk us through that thinking. I mean, you're at Anduril, you've seen that side of the realm, you've got your F-22 time, so you've seen both sides of the coin here.
No, Doug, I can't think of a single thing of me that I'd be jealous of. But I think one thing that is important here is the value in that teaming construct. And for those of you, listening along at home, page 6 is exactly this point in the TTX paper detailing do not trade 5th generation and beyond piloted fighters for the CCA. It is because these things are fundamentally additive and a support, not a replacement whole cloth for these crewed capabilities. We still fundamentally at a philosophical warfighting level want to have people making these decisions. We are not going totally human off the loop on these vehicles. Humans are going to be on the loop, not necessarily deeply in. And if you think about, you've seen videos on YouTube or watched something on this Discovery Channel or History Channel showing how current unmanned systems are operated. You have humans making every single decision ranging from the airspeed to the heading to the altitude. And now what we want to do is have and enable Raptor 1, Lightning 1 to be able to say or give a command and have that CCA go do it in a very similar way that man fighters and wingmen do right now. And so these are additive fundamentally to the crewed capabilities of these vehicles. Nobody is seriously advocating for, nope, let's cancel F-35s for unmanned systems. Nope, let's cancel F-47 and just go all in on unmanned, because that teaming of that crewed and uncrewed platform is where you do get 1 + 1 = 3, because the unmanned systems, you can put them into scenarios that you don't want to be in, but might be advantageous for that operation today. And the opposite is also true, where you might want to send that unmanned system back home and you go take care of something because of the strange nature of it or just a very unique situation. But you have to have the opportunity to make that decision. And how you have the opportunity to make that decision about whether the manned or the unmanned system goes and does it is you have to have those both. And so nobody's advocating for that, and I'm excited to continue to beat on that drum.
No, I think it's really 2 and 2 = 5, but you got to have both sides of the equation to net that. So Otis, the participants also emphasized the need to look after munitions accounts as we keep growing the number of weapons bays that CCA bring to the fight. And teams ran out of weapons after a few days. And obviously, this is something that happens throughout the world right now. We see Ukraine stressing this way, actions in the Red Sea. We just have too few munitions. So how do we get to a world where munitions are able to flow into the theater at a sustainable rate? And what does that mean for logistics demand? It's a big topic, but thoughts for the group?
Yeah, it's a great question. As you said, right, we have a logistics, we have a production limitation when it comes to munitions across the board. And the department's put a lot of time and effort in trying to increase the defense industrial base, whether it's for rocket motors, whether it's for the energetics, or whether it's for the sensors and things that go onto the weapons, like AMRAAMs or soon to be the JATM. I think, though, one of the things that we've done in the last 50 years is design our weapons around the current airplane, right? And then so the AMRAAM, for instance, we designed the F-22 and the F-35 to fit the AMRAAM. Right? And so I think what we need to do is to move away from that a little bit when it comes to CCAs. We know CCAs are coming. They are going to be the preponderance of forces. We're always going to have, or at least in the foreseeable future, we're going to have 5th and 6th generation fighters that are alongside of these aircraft. But we need to start designing weapons that are optimized to be carried on the CCAs themselves. Right? And spend the time and effort to do that. You'll get a much better weapons depth. Right? And then we can actually increase even more the defense industrial base, right, to produce. So we're not competing with the manned aircraft. We don't have enough air-to-air weapons to be able to supply our manned aircraft right now, let alone as we bring these up. So we need to spend the time and the effort, 1, on weapons, and 2, on the mission systems that will go inside of the CCAs to optimize for cost and effectiveness for the CCAs themselves.
Yeah, I'll add that the Air Force just released an RFI to suss out the potential to develop those munitions that are optimized for CCA weapon base. You really don't need to be a military expert to understand that increasing the number of targets an aircraft can attack per sortie, manned or unmanned, directly impacts mission success and a high-level campaign success. So that's why the experts in our last two exercises, including Otis, recommend the Air Force assess the value of creating new weapons or modifying existing weapons to, again, maximize targets per CCA sortie.
No, that's crucial. And Scar, I know you and your team at Anduril are working as directly with some new weapons. And Fug, you've lived in this world with types like the MQ-9. I mean, it's radically changed how we thought about munitions employment and the requirements. I mean, thoughts from you guys?
Yeah, when it comes to novel munitions, it really it comes down to that manufacturability. It's a common thread actually between the CCA program and munitions and a whole bunch of other things. Like as Otis alluded to with the MQ-25, we have maybe some practices in how we develop and manufacture aircraft, which are great and useful in some scenarios, but in a conflict that requires mass, you may want to go about doing things differently. And so when it comes to CCA, munitions, et cetera, I'll just keep leaning in on designing for manufacturability. Designing for manufacturability is the critical enabler to that scale procurement. And then providing, after scale procurement, those munitions in the field to be used by our operators. And so whether it's a munition, an aircraft, something, undersea, whatever it is, you now going forward must design for manufacturing for scale.
To Doug, add one little bit. It said no fighter pilot ever, at least that I've ever heard. I have too much fuel, or too many weapons, right? So it's just something that, like I said, I've never heard that. So yes, present munition stocks, we can certainly improve. I think we would all agree on that. The MQ-9, recent operations in CENTCOM with Strike Eagles and Vipers and everything, they show that we probably need to think differently about force composition and how we innovate with weapons. It's just what we're seeing. Some people would argue you could probably pull that from Ukraine as well. In our case, the workshop, so this TTX, really highlighted kind of multiple points where various kinetic and non-kinetic payloads in CCA could also help us achieve a desired effect, right? So much like we've seen with, we'll call it MQ-9s and other uncrewed systems, and a wide range of payloads that they can bring to the table, the various payloads that support different combatant command requirements. If we focus on kinetic effects, let's say, we can see opportunities to do design weapons that may be something that's more optimized for autonomous collaborative platforms. So I think as Otis said, and Scar was highlighting too, for years, it's almost like we built aircraft around a weapon. We've said, hey, we've got the MRAM or we've got the 8-9, we kind of build the aircraft around that. But in this case, how do we design weapons, as Scar pointed out, for scalability to mass, to affect the mass that we can bring to the table with CCAs? Maybe this doesn't help us in the immediate situation, but maybe what we're going to have to do is we're going to have to fly and evaluate and develop TTPs for employing various mixes of these aircraft. But I will go back to, we don't have to wait for the non-kinetic payloads. We can certainly generate effects in the battle space. I think Otis, Scar, myself, we've all seen the havoc that some well-placed, well-timed non-kinetic effects can have. And so it's those type things that I think once we get these capabilities in the hands of the warfighters, they're going to start to figure out how we can do those other different things short of just having, immediately more weapons available.
No, absolutely. So Gonzo, if we talk about, adapting things to the world that will be, not, shoehorning the future into this legacy model, how does the logistics force need to evolve to ensure that it is maximizing what CCA can bring to the fight, not CCA having to accommodate the legacy, logistics force?
Yeah, that was something that popped out of our last exercise at CCA. The consensus, really, of our participants was the Air Force needs a trained and well-equipped CCA cadre that know how to operate differently than they operate on our main operating bases. And the Air Force might need additional end strengths for that to happen, frankly. It simply cannot rob Peter to pay Paul, as it's been doing for decades to resource these new innovative aircraft. So with those trained cadre, it's not just a matter of resupplying and rearming and refueling them, but also to get them into the mode of operating that we're going to be here for 8 hours. We're going to service X number of CCA. We're up and gone on the aircraft and out to the next location, and just keep up that battle tempo for days, maybe even weeks at a time.
Yeah. The rest of you have any dream sheet requirements from the logistics side since you're building this stuff?
Yeah, I do. I mean, I do think that there's a new AFSC, that'll be built out of this. This idea that you can be a civil engineer, you can be an aircraft crew chief, right? You can be an avionics specialist, and then do all of the base support structure at the same time as you're maneuvering yourself around in this agile combat employment. It may not necessarily be the most efficient way of doing business, but warfighting is about resiliency.
Yes.
And we need to shift our mindset over to that resiliency, how to operate under fire continuously to not cede that space to the enemy.
Yeah. We also heard from the participants that not only were they thinking of unmanned for power projection, they're also thinking unmanned could enter the arena when it came to sustaining the force logistically. I mean, they were using MQ-9s as munition haulers between locations and things like that. And there's some other tech we read about in places like AVWEEK and all of that, where we see autonomous airlifters and things like that entering the fold. What are your guys' thoughts on that? Do you think that there's an advantage to allowing unmanned to enter the logistics realm like that?
Yeah, I mean, I think the big takeaway from me in this exercise was that you can have a relatively small aircraft that will move the preponderance of your to the edge logistics requirements, specifically for CCAs. We modeled both a Caravan and a King Air that we just said was autonomous, right? And they have that capability today where we can maneuver or we can put the preponderance of our logistics requirements on those and get them out to the field and to the edge.
Yep.
And I think that really was a huge game changer, especially when you can also just use the organic fuel that's sitting out in some of these general aviation areas to give that operation capability to CCAs.
And I'll just dovetail directly into what Otis said here, which is every pound of equipment that's moved by an unmanned system is a pound that we don't have to go logistically track on a C-17 or something else, that we'd rather go do something higher risk or more specialized or truly requiring a human. When we're trying to move black boxes, avionics, or weapons or whatever from point A to forward, the maximum amount of utility we can put into that unmanned system to make that movement happen, again, just drops the demand on those crude platforms that we'd rather just go do other things. And so it is a key enabler to have unmanned systems support this capability.
That's huge. So Gonza, we talked about this sitting in conference rooms. How do we actually make this happen in the real world?
Yeah, we talked about getting CCA in the hands of our warfighters as soon as possible so they can discover new ways of operating them and sustaining those operations. We found that to be true with every new weapon system we put out. But it's not going to happen if DoD doesn't fully fund the Air Force's CCA programs. It's not going to happen if the Air Force gets that dribble of funding that will just allow them to release these out into the field in 10s and 20s instead of the many hundreds that are needed, frankly, right now.
No, that's hugely important. There's another point here in just use cases and all of that. When we talk about the future fight, attrition is going to be huge. And I can look at things like the Battle Atlantic in World War II, where you had to have the destroyer escorts and the PBY Catalinas providing air covers to ensure the convoys got through. We had to build ships in sufficient quantity that you could lose some and you weren't going to tank the entire enterprise. How does this idea of fighting with resilience and a big enough force to be able to handle attrition, how does that really factor into what you guys think about?
There's significant risk from where we intend to fight in the future in the Western Pacific. I will tell you that I'm concerned that attrition on the ground might be greater than what we experience in the air. Why? Because China knows, just as we do, that the best place to kill an adversary's air force is when it's on the ground between sorties. So I see a future where CCA could help perform air-based defense missions. And during our exercises, the experts teamed CCA with 4th-gen fighters to counter the PLA's long-range attacks against the Air Force's E-7s and tanker aircrafts. And that's really the lifeblood of an air campaign, being able to generate the sorties on the ground at scale and then refuel and do battle management in the air. So CCA can help counter the threats to those operations, those capabilities, capacity that warfighters need.
Yeah, I mean, the way I think about it, so attrition is really about handling both the risk and the depth, right? So first off, by having CCAs, we can manage the risk, increase the risk levels if we need to, because we're going to have more of them, just from a resource point of view, because they should be, or they will be less expensive, and we'll have more resources available to purchase them than we would a fifth or sixth generation fighter. So it'll allow us to change our risk calculus, right, to push things forward and to handle a little bit more attrition. And then the second aspect of that is really the depth, right? The just how much forces can you handle, whether it's on the ground, right, or whether it's in the air, to be able to handle attrition. So as you spread out your forces, right, you invert the cost curve. It costs the enemy more to actually try to attack because they're all spread out, as opposed to being able to launch 3 or 4 weapons and take out your entire force structure that's sitting at an MOB. So I think that CCAs are fundamental to be able to handle attrition warfare, should it come to that in the Indo-Pacific or anywhere else for that matter.
That's hugely important.
Hey, Doug.
Yeah.
If I just one piece that I do think is important here and often overlooked, and we've kind of talked around it a bit, but the most precious thing on the battlefield is the human capital. Right? Resources, the maintainers who are going to turn the aircraft. And, and I know Scar's team and our team at GA, we've looked at this. We've taken great lengths to go all the way back through in the digital engineering side and figure out how do we reduce the burden on that individual, on that human who are asking to turn our aircraft under potentially intense combat operations, things that we haven't had to do. And so I think, Otis hit on it, Gonzo definitely hit on it, but this concept of, minimizing the time I'm on the ground, right? Designing an aircraft to minimize time to turn on the ground. That's not something that we normally talk about when we look at kind of how we design 5th gen aircraft. In CCA, it is a real design consideration. Right? And we've looked at it extensively. The fact, and Otis has really kind of captured this, that we can roll into what I would just call a more general aviation style airfield and refuel and potentially rearm an aircraft. But those are game-changing things, certainly, and they bring a different dimension to air power. But I'll also kind of come back to, it's also about reducing that manpower footprint that's required to turn the aircraft, right? So how many humans I have to put at risk. And I really just want to highlight that, because those are the things we can't easily replace on the battlefield. We can crank out machines, we can figure out ways to get weapons in there. But when we're starting to design with considerations for how we can enable the Air Force to better manage and better protect its humans, I think that's something important that we really need to capture.
That's awesome. Okay, we're tight on time right now, so let's do a lightning round for last question. If you each had $1 more, where would you spend it to improve the logistics force, especially as it relates to CCA? Scar, let's start with you.
Yeah, I'd start buying stuff and pre-positioning it now. As Otis alluded to earlier in the podcast, we've really designed for efficiency and just in time. I think we need to pivot ourselves to just in case. So having replacement parts, engines, wheels, tires, everything stacked up forward now to facilitate that rapid turn and minimize the attrition on the ground as we fix airplanes. I think I would be starting to stack up replacement parts right now.
Yeah, I can't agree more. I mean, I think that that's brilliant. I also think that we should be buying, rather than focusing solely on the logistics, the best way that you can understand what the logistics footprint is going to be is to start operating these things today.
Bingo.
Right. And so the faster that we get something out into the field, doesn't have to be the perfect thing. We start flying it. We get our maintainers, we get our pilots, right? We get the support personnel that can go, oh, you know what? If we just did X, Y, or Z, we can take 15 minutes off, an hour off. We can reduce this logistics footprint even farther. The mere fact of, hey, you guys really, in our TTX, you guys really should think about overwing versus single point refueling. Happily enough, the engineers did, right? And we designed, everybody that has an airplane is designed for that capability. But there are going to be other discovery learning things that happen when we start operating these things. We need to stop waiting. We need to start fielding, get something in the field today, operating it today, at the 50%, whatever, 90% solution, and we'll learn as we go.
Fuck.
Yeah, so I think all of us have really hit on the fact that we need to drive the logistics to the minimal point, right? Reduce the tail, reduce the stem, reduce all those things forward. I think to me, a clear parallel is, hey, if I have $1, I'm going to invest it in what does a collaborative mobility thing look like that can intelligently support my collaborative combat aircraft in the battle space, right? How do we do that? How do we, I'll call it at a rapid ops tempo, support smaller logistics footprints? Again, we're flipping what we're normally used to, right? We're used to plain little C-17s coming in and supporting, offloading pallets of material. Well, what we're talking about here are hundreds of pounds of material to support. If I exclude weapons, we're talking small amounts of material forward, right? So what does that aircraft, that next generation, as I think as Otis alluded to, are we taking caravans? We're going to use the things we have. We're going to take pods on MQ-9s. How do we get after that? That's the part that I think we're seeing the trend. And Solo pointed this out. When we see the trend data, we have to acknowledge the trend. And here the trend is we're intentionally designing to reduce that logistics footprint forward. So what does that mean in terms of mobility support or logistics support?
Yeah, I'll second, third, and fourth, everything they just said. But getting beyond the dollars a little bit, our experts also recommended that the Air Force, working with rest of DoD and State Department for that matter, start building the host nation agreements to get the kinds of heavy materials that could provide to our CCA locations, like fuel, like water, like food, and so forth. Because if you don't have to haul that in, yeah, those are C-130 sorties that could be supplying other forces. Those are air crews that are no longer at risk. But you've got to build those host nation agreements now, not in a crisis, because it'll be too late by then.
Now, guys, you've been awesome. We're at the end of our time block, but I cannot thank you enough for all the thoughts you shared today.
Thanks for having us.
Absolutely.
Thanks for the time, guys. See you next time.
Thanks, Doug. Thanks, everybody.
Hey, take care. And with that, I'd like to extend a big thank you to our guests for joining in today's discussion. I'd also like to extend a thank you to our listeners for your continued support and for tuning in to today's show. And if you like what you've heard today, don't forget to hit that like button and follow or subscribe to Aerospace Advantage. You can also leave a comment to let us know what you think about our show or areas that you think we should explore further. And as always, you can join the conversation by following the Mitchell Institute on Twitter, Instagram, Facebook, or LinkedIn. And you can always find us at mitchellaerospacepower.org. Thanks again for joining us. We'll see you next time. Good job, guys.
Good show.
Thank you.
Hey, that's a wrap.
Otis, I'm driving you to the hospital, man.
I'm all right.
You get.
I don't think the heavy stuff's going to come down for some time.
I found myself like sympathetically coughing. Like, what is going on?
You're the man, Scar.
It's like,
Yeah, I got an opinion here.
I'm ready. I'm actually, I have a side hustle that I'm going to start. I'm going to be like the 1-800, creepy old dude in the background for OnlyFans. It'll be great.
Scarf, what you can't see is this entire room is filled with Camel cigarette smoke right now. We can't see each other.
Yeah, come on.
It sounded like Otis hid the cigars and whiskey from someone's stash there in the building.
I would love that. That would mean I'd get all the benefit and then deal with the pain. Now I just get the pain.
This is actually unproductive throat problem.
Exactly.
Like the other, like you could have gotten this in a productive way, but no, dude, man, you need to go to the hospital, son.